Hi, I'm Rodney. I'm going to talk about entering DR. Most of the time, you're going to do this by starting from four bad corners, four bad edges, using DR moves on the UD axis to set up an R trigger. And there are moves, there are lists of all the like the 5 move sequences that'll get you to DR from there. But there's like over 200, and who wants to memorize those? Plus, sometimes like 6 or 7 moves is going to be good, but you're definitely not going to memorize all those. You can get pretty far with intuition, but what you might find, what I found with intuition, is like, oh, if I prioritize forming the bars, then sometimes my corners are in a bad state, and so I'm trading that off, and I'm wasting time looking for things that end up having like 10 move optimal or something. So I wanted to develop some theory to guide you into intuition, so you can quickly recognize whether something uh, like a minimum move count bound for a case, and to help you find kind of an optimal solution to the setup linearly. So I'm going to share what I came up with. So the way we want to analyze these out of DR cases is by tracking the positions and the orientations of the bad corners separately. So for 4C4E, this is your target state. You want to set up this R trigger, and so you have 4 bad corners, and they're in this position or this position. So equivalent by half turn only moves. It could look like this, or like this, or like this. So this is the 0 QT state for the positions of the bad corners. If I make a quarter turn here, then this is a 1/4 T. I call this slashes, so the bad pieces are here and here. That's 1/4 turn away, and then the other quarter turn away, it can look like is this. This is the 1 QT bars, I'm going to call it, which I can flip with a half turn to make the bad corners split 3-1, and then another U move gets the bad corners 3-1, where these are stacked on top of each other. This is the 2 QT state. These patterns come up in HDR. They should be familiar. They're the same as the UD orientation patterns in Hyper-Parity. Now, the difference with Hyper-Parity is that there are 2 kinds of bad corners, because a corner can be rotated either clockwise or counterclockwise, according to the white face. So this one is rotated one click clockwise, and this one is rotated 1 click counterclockwise. So there's 2 kinds of bad corners, and there's always going to be 2 of each. When you're in this 4C4E state, when you're in any 4C state. And I'm going to call the ones with the same orientation, the same rotation, interchangeable. So this one and this one are interchangeable because I can move this sticker to this position, but I can never move this sticker to this position with DR moves on the UD axis. So the key is going to be for each quarter turn case, I'm going to have certain HDR orbits, and the bad pieces, the 2 bad pieces of each type, bad corners of each type, are going to be located at different places in different HDR orbits, potentially. So the HDR orbits are the ones that don't change, the positions that don't change under half turn moves. So this is one HDR orbit. These 2 plus these 2, half turns just swap them between that set of 4, and the other HDR orbit is these 2 plus these 2. So that's going to break down our original 4 cases into a larger number of subcases. So here are the subcases of the 0 QT position case. The target case has each orbit containing 2 interchangeable pieces. So this is one orbit, these 2, and this has these 2 pieces, these 2 bad pieces that are both interchangeable. The other orbit is these. And it has the other 2 interchangeable pieces. So that's the target case where I can solve the corners with just a U. But I might also have the pieces distributed differently between the orbits. So in this case, I've got one orbit as these 2, and these pieces are not interchangeable. They have different rotations. And then the other orbit has these 2, which are also not interchangeable. So this is, even though the positions are all here, you can't solve this with just an R. And the other way that can look is this way. So just notice for the bad pieces here, they're here like this and like this. And in this case, they're here and here. But these 2 cases are interchangeable with half turns. If I do an R2, U2, F2, then I've got the same case here. That's because R2, U2, F2, U2 swaps these 2. So I still have one orbit with non-interchangeable pieces, but they might be, but I can swap these two with half turns. So two cases for 0 QT. So these ones are actually 2 quarter turns, even though the positions are 0 quarter turns. So to fix this case, I need to swap two non-interchangeable corners that are not in the same orbit, and the only way I can do that is to introduce a quarter turn, 2 quarter turns. If I swapped these two, then I would be in a good state. So the quickest way to do that is R2U F2U prime. And so that's the quarter turn to get into that. But of course, most of the time, you're just going to want to avoid entering that state in the first place. In the 1QT slashes case, position case, all the bad corners are in the same orbit, so there's only one case. All you have to do to make sure that you enter the 0 QT case instead of the 2 QT case is make sure that these top pieces are interchangeable. So this will set up a good corners, and if they're not interchangeable like this, then you'll set up bad corners. Let's look at the 1QT bars case. This is the good case where if I look at the two orbits, this orbit has two non-interchangeable pieces now, and this one has two non-interchangeable pieces. So this is the good one that can be solved in 1 quarter turn. That can also look like this. So you might look at this and think it's a bad case, but this is actually half turn, can be fixed with only half turns. Because again, I have one orbit with two non-interchangeable pieces, and this orbit also has two non-interchangeable pieces, so it's transformable into this. And the way to do that is F2U to R2, and now I can solve that with a quarter turn. The bad case is actually this one, where this orbit has two interchangeable stickers pieces, and this one has two interchangeable pieces. And it's particularly easy to recognize because all the stickers are on the same axis, so it might look like this or this, but you can tell that it's different in that sense. This requires 3 quarter turns to solve. The way I need to solve it is to exchange non-interchangeable pieces. So one way to do that would be like this. I can go to 2QT and back. Now that's set up. So I set that up so that I could swap these two pieces, which are non-interchangeable. But more likely what you're going to want to do is maybe look for JZP. So JZP or a DR breaking move. I'm not going to talk about those in those videos, but if you head up with these corners, those are likely to be a better option. So let's talk about the 2QT case. In this case, there's only one orientation case. One orbit has 3 pieces, and the other, so it has to be 2 interchangeable and 1 non-interchangeable, and then the other orbit has the other piece. So there's only one case. So the only thing you have to be careful is to make sure you set up to go to 1 QT instead of 3 QT. So the way easiest way I think to recognize that, you have to set them up so that the bad pieces are split 3-1 between the UD faces. But also, I think easiest for me to is recognize if these two bad pieces that are stacked on top of each other on the same face, then you're set up. So then I can do a quarter turn. But if I do UV2, now notice I've got the one QT case where these interchangeable pieces are on the top. So instead of setting up with UV2, I should do U prime R2. And then I have the corners. If I'm in a case like this where the pieces stacked on top of each other are in different on different faces, then I can't do a U-turn to set up 1 QT. Then this will lead to 3 QT, because then after I do the 1 QT, then I'll have all these 4 bad stickers on the same axis. And so that's the 3 QT case. So if you're here, you have to set up, I have to make, if I can swap like these two, then you do like that, then I'll be set up to enter 1 QT. So that's the thing you have to be careful of when you're at 2 QT, is how to set up to make sure you go to 1 QT and not 3 QT. The other way, of course, this case can look like is this bar slash pattern. So bar slash. Notice the bar slash here I've got, I still have two pieces that are stacked on top of each other somewhere. Here they're on different axes. So I know that if I set this up to 3, 1 like this, well, I'm still going to have one axis. So this will lead to 3 QTKs. So there are two ways to do that. I can do a U2 F2, and then I'll be set up. I can also just do a U F2, and that will also set up. So there's two ways to go from bar slash to to set up entry into the 1QT case. So now that we have the corners mapped out, let's move on to finding the full solution to enter DR, accounting for the edges. I had an earlier document on DR setup theory that tried to provide an estimate for the number of moves needed, but it didn't work too well. It was only looking at pairs, wasn't accounting for the fact that you could sometimes solve pairs for 3 while solving the corners. So I'm going to account for that now. And the goal is to be able to look at, say, a case like this. So this is 2 quarter turns away, and it's got 2 pairs. And here's a case that's 2 quarter turns away. It's got a full bar formed. Which one of these is better? I'm going to tell you how to figure that out without having to do any moves. Also here, here's another one with 2 QT. It's also got 2 pairs. Which one of these is better? So we're gonna kind of account for all those in our estimates. So my target state, of course, has 2 full bars formed. I'm going to count that as 4 pairs. So a bad edge, a bad corner on one side for 1 pair, a bad corner on the other side for 2 pairs. So that's 2 pairs, and then the other bad edge will have 2 pairs as well. So I need to form 4 pairs in the course of solving the corners. I can form a pair only when I make a side move, right? I won't form a pair with any U or D move, but every RLFB move could potentially form a pair. And so I'm going to add a penalty for every pair that I will need an extra move to solve. So, for example, this case is 2 QT corners, but it only requires 4 moves to solve. So that's going to be like U star R2 X2 U star R. So that's 4 with 1 side move. I have 2 pairs already formed. I have 1 side move opportunity, so I'm going to need at least 1 extra move. So this has a minimum move count of 5. The solution for this case is in fact 5. I'm already set up for corners, so I can just do this U prime and then B2 R2. So that's the extra move that I needed to form an extra pair. So instead of, I could have solved corners in 1, but I needed 2. That's inserting a corner swap, in fact. So it's inserting a corner swap, 3 minus 2, to enter DR. So this is the best case at 5. The other penalty I call the slice penalty. So if you notice, like an optimal trigger has the bad edges in different slices. So one in the M slice, one in the S slice. But if you're at 1 QT corners with bad edges in the same slice, then you just have a longer setup. So this is 1 QT corners, but when I bring all the corners to the bad face, instead of just doing an R move, I have to do this R2 U2 R. So you can count +2 if you have a case where you have you're at 1 QT corners, but you have the bad edges in the same slice. So that brings us to this case. So this is the case where I'm also 4 turns to solve the corners, and I have 2 edges, 2 pairs. So just like before, this would take 5 to solve, except I have this slice penalty. So it's actually going to take me 7 to solve. That looks like this. I'm set up to 1 QT corners, but if I go like that, 1, 2, then I have this case 3, 4, 5, 6, 7, 8. So and that actually required 8 because I needed an extra move in order to accommodate the E slice. So this estimate doesn't account for the E slice, but still I could tell this was not a 5-mover solution because I had minimum of 7. Let's go back to this case and look at it now with those penalties in mind. So I had the bar, that's 2 pairs formed, but my corners are set up not to enter a 1 QT, but to enter 3 QT. So to set that up, I need to do a U2 F2, so that's 2 to get to the 4 move corners. So that's at least 6, And what's my pairs penalty at that point? If I do U2 F2 to avoid the slice penalty, now I still have only 2 pairs, only 1/4 turn. So my 6 move is going to get a 1 penalty. So this is at least a 7 move. So here's the headline. You now have a way of recognizing 5 move, 6 move, 7 move DR setups without any rote memorization. Just learn the corner cases. There's only 6 of them. Make sure you don't go from 2 QT to 3 QT corners. Make sure you don't go from 1 QT to 2 QT corners, and then count pairs. And you can easily tell whether it's worth looking farther. The other cool thing is that since you don't actually have to execute any moves to tell whether it's feasibly a 5, 6, or 7 setup, you can NIS predict pretty easily. So if I get a bad case, it can be pretty time consuming to NIS all your RZPs, but if I can just trace the corners and say, my white stickers are here and here, oh, that's a one corner case, 1 QT corner case, oh, and I have 1 pair, and the bad edges are in the different slices, so oh, that's going to be a good one. So that's worth NISing for, and then you can save yourself a lot of time not pursuing dead ends. So that's the theory. I really think this framework of identifying the cases by the position of the bad pieces plus the distribution of the interchangeable pieces between the HDR orbits is the right framework. I think it can be extended to other cases for approaching DR. We'll see what comes of that. But I do think that since I've worked this out, I spend a lot less time fumbling around with deceptive cases that look good but really aren't. When I do focus on something, I can get even 7, 8, 9 moves setups linearly. So that's helpful, and I love the fact that the NIS tracing is easy and saves time there too. So hope you find it helpful to you too.